Hi, my name is James Lin. I'm a staff system application engineer for MassLinear HPA serial and bridge product line. Today, I'm going to introduce MassLinear's multi-protocol transceivers design, sharing same pin out on DB9 connector. Before introduction, let's go through the difference and advantage of a standard transceiver and a multi-protocol transceiver in case of designing a multi-interface system. Using traditional multiple transceiver design, because more chips, connectors, and components are needed, it requires more PCB space for placement. Not only the size of the product cannot be reduced, but also termination resistor conflict problems. Using integrated multi-protocol transceiver solution that combine both types of transceiver in a single device. Complex switching through external components is not required, through reducing the overall footprint on the circuit board and support a wide variety of applications. The signaling pins on multi-protocol transceivers are shared between the RS-485 and RS-232 transceivers. It's convenient to configure mode or enable integrated feature at any time. Many industrial communications and networks need to support multiple interfaces, like RS-232, RS-485, RS-422, and RS-530. In this application scenario, multi-protocol transceiver is the most suitable choice. But in the design process, we often encounter one specific problem. The connector cannot be shared between the different protocol interfaces. This video provides you a solution to solve the problem. It allows sharing the same connector pin out for RS-232 and RS-485 interfaces. In general application scenarios, RS-232 and RS-485 connections cannot share the same connector. This is due to the pin out of RS-232 mode TX, RX, and the pin out of RS-485 mode Z, B, Y, A are defined different on the DB9 connector. As shown in the figure, in standard DB9 connector definition for RS-232 mode, pin 2 and pin 3 of the DB9 connector are RxD and TXD. However, when in RS-485 mode, pin ZB and YA is connected to the DB9 pin 3 and pin 7 of the DB9. Therefore, if the same connector for RS-232 is used, it will result in a data error or packet loss. For the convenience of use, as well as saving PCB space and cost, we can make the connection of the TX, RX, Z, B, Y, A, and the DB9 connector compatible with the RS-232 mode or RS-485 half duplex mode. By doing it this way, no matter which mode you switch to, you can use the shared connector to transmit data without additionally removing the cable to other connectors. In order to achieve this, utilize the multi-protocol transceiver's characteristics and work on the pins in the floating status under specific mode settings. For practical implementation, we can utilize the RXIN pin in the RS-232 mode, which is floating pin under RS-485 half duplex mode. Adding the external FET switch allows user with ability to connect the RSIN pin and the TX out pin together under the RS-485 mode. When RS-485 RS-232 mode slap pin equal to 0, it is configured to RS-232 mode. The FET switch will be turned off. The RSIN pin will be disconnected from the TX out pin. When RS-485 RS-232 mode slap pin equal to 1, indicating the device is configured to RS-485 mode, the switch will be turned on, resulting in RSIN pin connecting to TX out pin. With this FET switch implementation, it makes sure that both RS-232 and RS-485 hub duplex connection works correctly with the same connector and pin out as defined. By adding this switch design, you ensure that RS-232 and RS-485 hub duplex connection works properly with the same connector and pin out. You can see the data output from pin 2 and pin 3 are correct in either RS-232 mode and RS-485 mode. In this way, the connector can be shared, which is more convenient to use in practical applications. The benefits of using multi-protocol transceivers. First, to simplify the system design using a single device switching between modes. Design with a multi-protocol transceiver can reduce components number, PCB space, avoid potential problems such as a resistor conflict, and so on. Second, a solution using a shared connector pin-out can be implemented in real application. To learn more about MaxLinear's multi-protocol transceivers, please visit www.maxlinear.com. Thank you for watching.